Today we're going to be talking about the stack. So what exactly is a stack? Well, the stack is basically just another type of container, like a vector or array list in C++ and Java respectively, and it has LIFO or last in, first out semantics. In LIFO, we can only remove the topmost or most recently inserted item. So think about like a stack of paper. If we have a really large stack, what can we only do with it? Well, we can take out the topmost paper. Or if we had a deck of cards, we could only take out the topmost card. So you can pretty much think of stack like a stack of paper or a stack of anything really. So let's talk about the stack uses. So for stacks, imagine we already have this stack in the following, where we have two items here. For stacks, we really just support three really important features. Number one, push an item or add an item to the top of the stack. Number two, top. Top basically just texts the most recently inserted item. And finally, pop. Pop is basically just telling us to remove the top most recently inserted item. Okay, so let's talk about some of the details with stack. And the first thing that we already mentioned was that it uses LIFO or last in first out semantics. And we can only remove the top most recently inserted item. So let's take a hamburger for example. This hamburger, we have the following instructions. Imagine we already had the following ingredients. So on the bottom, we had a bun, then some lettuce, a patty, and then cheese. And let's go through each of these instructions one by one. So let's do pop. Pop, we're going to take out the cheese. Let's say we didn't want cheese. So then the cheese would be removed. Then let's push an onion. Well, what happens if we push an onion? Then the onion gets put on top of the burger. So here we go. Let's put it on. Let's put a tomato on, so push a tomato. Let's say now we decided, oh, I don't really want a tomato. So let's take it out. Let's say I also didn't want onions again. And finally, let's complete our burger by just pushing another bun. And there we go. So here's our final burger, a bun, lettuce, patty, and then a final bun. Okay, let's talk about some of the applications for stacks. Well, stacks can be used for many special purposes. They rely on dynamic reverse withdrawal of elements to function. So some examples you might see are browser navigation, the undo mechanism, change of base, and postfix evaluation. These can be further explored by further studies. So let's take the example of the postfix notation. Postfix notation is a method of writing mathematical expressions where operators are after their operands and not between. So for example, typically we might see 2 plus 2. Well, what that becomes is 2, 2, and then a plus. And for example, if we had 2 times 2 and then divided by 3, that becomes 2, 2 times 3 divided by. So let's try it out. Let's see how we do this. So the idea really is when we see a number, push it onto the stack. And when we see an operator, evaluate the top two values using the operator, and then push it back onto the stack. The last remaining number is going to be our answer. So take this really large expression, for example. So what does this look like, or what does the answer evaluate to? So remember our semantics or our rules were whenever we see a number, push it onto the stack. And when we see an operator, evaluate the topmost elements, and then push that new value onto the stack. So we see a 3, we put it onto our stack. We see a 7, also put it onto our stack. We see a plus, evaluate 3 and 7, which is 10, and then add that to our stack. We see the 4, add it to our stack. The multiply operator, so 4 times 10 is equal to 40, and put that back to our stack. We see an 8, we see a 2, and then now we see a division symbol, so we take the top two elements and divide them. So here we get 4. Put that onto our stack, and then finally we see this minus symbol, so we do 40 minus 4, and we get 36. Put that onto our stack, and since we're no longer have any operations or operands, 36 is going to be our answer. Okay, so now let's talk about the code. So in terms of the code right now, what I have is just a Java buffered reader template so that it's easier to take in input, but you can just do this with scanner as well. So the first thing we're going to do is just take an input for our string, and we're going to say is equal to read line. So that's the equivalent of sc.nextLine. And we're going to split all of the elements or all of our numbers and characters by spaces. So this will basically just create an array of all the elements for us. Okay, the next thing that we're going to do is we're going to create a stack, and it's going to be of type integer. And we're basically just going to write is equal to new stack. Okay, so here we've created our stack that we can use for our solution. The next thing that we're going to do is we're just going to loop through all of our elements here. And we're basically just going to take out the current element. So that's going to be s of I. And basically we just need to distinguish between numbers and operators, operators. So how do we check if a string is actually a number, and how can we actually parse it? Well, basically all we need to do is just check whether or not the first character of that string is a digit. So to get the first character of a string, all we do is just say cur.char at 0. So this is basically just getting that first character. Then we just need to say whether or not this is a digit or not. So whether or not it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's pretty easy. Java even has a built-in feature for us. That's character dot is digit. So we can wrap that around this function. And if it turns out to be a digit, all we need to do is say stk.push integer dot parse int cur, and there we go. So this will basically extract the string and turn it into an integer, and that'll allow us to push it into our stack. Otherwise, we just need to handle the the 4 operations with the 2 operands. So we're going to first take out the 2 elements from the stack. So that's just going to be stk.pop, and operation 1 is going to be stk.pop again. Now, the reason we do it in this order is because think about it like this. Imagine our stack was something like 8 and then 2, right? And then so let's say originally we said 8 divided by 2. And then in terms of postfix notation, this would become 8 2 divided by. And so in our stack, at the bottom, we have this 8, and at the top, we have this 2. So in reality, what we're doing is 8 divided by 2. So this bottom one is actually the second one from the top, right? And this 2 is going to be on the top. So that's why the 2 is the first pop, and the 8 is going to be the second pop. So there we go. All we need to do now is just handle all the operations. So if cur dot equals a plus, all we need to do is say stk.push operation 1 plus operation 2. If cur dot equals a minus, all we need to do is say stk.push op1 minus op2. If cur dot equals, let's say, multiply, then we just multiply them. Sorry. op1 times op2. And then if cur dot equals divided by, we just say stk.push op1 divided by op2. So let's try running this with a really quick example. 8, 2, and divided by. Oh, and we don't actually print anything because we just need to remember that the last, or our answer is actually just going to be the last element in the stack. So system.out.println stk.pop, and now it should work perfectly fine. So 8, 2 division, that gives me 4, and there we go. So let's actually try this on the Dualway Online Judge and see if this works. And there we go. It perfectly works. So that's it for stacks, and there we go.